geology. So the geology, the rocks that show us the evidence of this flood in Noah's day. And when you go and examine the Grand Canyon, you might even say, the rocks cry out. And they speak as a testimony of God's word being true. So tonight we're going to talk about flood geology. We're going to talk about 3 rock-solid evidences for a global flood as seen at the Grand Canyon. So once again, looking at these thousands of feet of rock layers that we see there, there's an interesting feature, a very big mystery, if you will, at the Grand Canyon, that is a very big mystery to most geologists. In fact, if you watch shows on television, you watch things on National Geographic or the History Channel or the Science Channel, inevitably what they will oftentimes talk about in those programs is a very big geological mystery known as the Great Unconformity. Now, can you guys all say unconformity? If you can't, it's right there. Unconformity. Now, turn to your neighbor and say unconformity. All right. Now, don't worry, you guys. That's the largest word I'm going to teach you tonight. And you might be saying, good, because I have no idea what that word means. So what is an unconformity? Well, if you look at the geology of the Grand Canyon once again, you can see on this picture where these tilted, angled rocks down below, let's see if this will work for me. Anyhow, the tilted, angled rocks down below, where they meet the flat, horizontal rocks. Can you see that? So you've got these tilted, angled rocks on the right, you see the docks and the Cardenas, and then you get to that Tapeats. At that line, there is a huge erosional boundary. You see those tilted, angled rocks down below should continue rising on up, but something has happened to shear them off straight across, to cut them off flat, and then stack up 4,000 feet of water-laid sedimentary rocks on top of there. A huge, major erosional event. And so that's kind of what unconformities are. There are multiple unconformities. This one happens to be called the Great Unconformity because, first of all, it's a pretty big erosional boundary. A tremendous amount of rock has gone missing from there. And this erosional boundary is a worldwide physical feature. The Great Unconformity, I've seen it close to here, at least close-ish, Wisconsin. Anybody ever been up to like Baraboo area? I've been to Devil's Lake State Park. So I was up there, and right there you have the exact same erosional boundary, the exact same Great Unconformity over there. And the exact same geology that I'm looking at the Grand Canyon, the exact same Tapeats sandstone equivalent is over there, and I'm looking at the rocks underneath at the purple Baraboo quartzite, and I'm saying, oh my goodness, this looks just like what I see in my home at Grand Canyon. This erosional boundary extends across multiple continents. So thinking about that, it doesn't take a whole lot of deep thinking to realize if you have a cross-continental, in other words, worldwide erosional feature, that must have required a worldwide erosional event. And when that worldwide erosional event can be shown to be made by water, that's a worldwide erosional water event. Sounds kind of like a flood, doesn't it? Let's talk a little bit about that. So if you're standing at the rim of the Grand Canyon looking down to that Great Unconformity, this is what you're going to see. So this is a picture I took a few years back from Lippin Point, and you can see one of the gals on our tour standing up on the rim looking down below. You can see the S-shaping curve of the Colorado River, and you can see the uncarved delta sticking into there. Behind the river, can you see how those layers are tilted? All that soft red sediment, and there's layers of red, some kind of black, some white bands, more red, more black. It's all tilted until about halfway up. And about halfway up, you end up getting to this kind of sandstone cliff unit that you see right there. The tilted rock, where it meets the flat rock, that is the Great Unconformity. So from the rim, it looks like that. From below, if you come on a 7 or 9 day river trip with me, it looks like this when you get up close. This is a place called Blacktail Canyon, and I was just there just about a week ago, about a week and a half ago. We did a 7-day river trip through the Grand Canyon. That was a trip with Dr. John Whitmore, who's a geologist from Cedarville University here in Ohio. Also with Dr. Terry Mortensen and Dr. Bill Barrick. And so the 4 of us taught this 7-day river trip through the Grand Canyon. We went to Blacktail Canyon right here. And if you look in this picture, which you can see these rocks underneath and then rocks going flat and horizontal, right? There is a very clear shear line right there. A very clear erosional boundary, right? So So looking down there, it looks again kind of like what you see here. This is Dr. Andrew Snelling. Some of you guys might be familiar with him. He works with Answers in Genesis, and they're the ones who have the ark over there outside of Cincinnati, that region. So you can see what Andrew's pointing to right there is the beginning of this Tapeats sandstone. Underneath him, you have the crystalline basement rock of schist and granite. And so we like to take people into Blacktail Canyon because what we're looking at when you examine these rocks, what we see here are the rocks underneath are representations of what was formed, we believe, on day 3 of creation. The book of Genesis, chapter 1, talks about the days of creation, right? And it tells us on day 3 of creation that God drew all the water to one place so that dry land would appear. These basement rocks would represent the rocks that were formed, we believe, on day 3 of creation. And then above that, you begin to see the beginning of this Tapeats sandstone. So this Tapeats sandstone is a massive erosional boundary, and this Tapeats sandstone, we believe, represents the first layer deposited by the flood in Noah's day. Because if you think about it, this flood, this was a really huge event, wasn't it? And it was catastrophic. And many times, when you mention Noah's Ark or Noah's flood to most people, the first image that pops into people's minds is oftentimes this cute little bathtub boat, right? With giraffe heads poking out of it, and animals barely able to hang on, some kind of Christmas tree ornament or snow globe looking thing, right? And guys, let me tell you, that is not what the Bible describes the flood in Noah's day to be all about. Rather, what it talks about this was a huge, huge flood, a huge, huge event. The ark was no bathtub boat. This was a vessel that was roughly 450 feet long, 75 feet wide, 45 feet tall. We're talking about a huge, massive vessel. I mean, this is like a football field and a half in length. This is a really big boat. Now, the reason that God has Noah build this ark so large is because, likewise, this flood is so large. And many times when you mention the flood, people oftentimes have a misunderstanding. And one of the reasons for that is many times when you learn about Noah's Ark or Noah's flood, we oftentimes learn about it in Sunday school, right? With cute little fun pictures and songs that go along with it. And we kind of have that little Sunday school cartoon image. And very rarely do we ever go back in big church, you might say, on a Sunday morning and ever talk about the flood from an actual, true biblical perspective. Because we learned that little Sunday school story. We already know that story, right? And usually that little Sunday school version does not give us an accurate or true understanding of what the flood was really, truly all about. So to understand that, we need to go back to the history book of the universe. We need to go back to the source and understand what does it have to say about this flood. When you read the scripture, it gives us a whole different picture, a much bigger perspective, you might say. You know, many times when you see a cartoon or Sunday school book, you see everyone standing around the ark, making fun of Noah, giving him a hard time, and all of a sudden, there's a raindrop on somebody's shoulder, and another little raindrop, and another little raindrop, right? You've seen the picture, right? And all of a sudden they look up to the sky and they say, what in the world? It's starting to rain. Maybe Noah was right after all. But guys, that is not what Scripture talks about regarding the start of this flood. Because rather than starting off with mere raindrops, Genesis chapter 7, verse 11 tells us about the beginning of the flood. And what it says is, the fountains of the deep broke forth. And then the windows of heaven were opened. Fountains like geysers, fountains of the great deep. In the Hebrew, that word great deep is the word tehom, which means the ocean basins. We're talking about huge, massive geysers shooting up from the ocean basins themselves. We're talking about the windows of heaven being opened, a tremendous downpour from above. Guys, this is no pitter-patter of rain, no drip, drip, drop little April showers. No, this is a major, huge, catastrophic event, a deluge in Noah's day, starting off with a tremendous amount of water. We're not talking about just a little bit of raindrops. We're talking about a lot of water. And a lot of water can do a lot more change and damage and destruction than just a little bit of raindrops, right? So we're talking about a lot more water than most people tend to think. And then the other thing we're talking about during this flood is a lot more time than what most people often think. You know, many times when you talk about how long was the flood, or you ask somebody, how long did Noah's flood last? The most common answer that we come across is Well, wasn't it 40 days and 40 nights? Anybody ever had that idea? Anybody still have that idea? I grew up with that idea because we sing little Sunday school songs, right? You know, it rained, it poured for 40 daisies, daisies. You guys know that song, right? I know some of you do, at least you older ones. Thank you. I'm not going to sing anymore. You're welcome. So what we see here, it's a lot more than 40 days and 40 nights. The Bible says it was raining for 40 days and 40 nights, but the flood does not stop there. As you continue reading that verse, it says the flood waters continued to prevail upon the earth. The ark was lifted up, and it actually tells us the flood waters continued to prevail upon the earth for 150 days. In fact, that's the last verse of Genesis chapter 7. The flood waters prevailed upon the earth for 150 days. Genesis chapter 8 starts off by telling us that God closed the windows of heaven and the fountains of the deep at that point. And then they're still having to wait on the ark because the earth is not dry. It's finally 150 days into the flood when the floodwaters finally begin to start to go down. So they're waiting for the floodwaters to recede, to slowly go down. And when they finally get off the ark, you can see it's actually an entire year later. This is a year-long global flood. Genesis 7:11 tells us it was the 600th year of Noah's life, the second month of that year, and the 17th day when the floodwaters began. And then you fast forward into Genesis chapter 8 when they get off the ark, and it says now it was the 601st year of Noah's life, the second month of that year, and the 27th day when they finally get off the ark. So guys, we've got about a year to a year and 10 days for a global flood event to take place. And that's a lot more time than what most people tend to think, right? So you add a lot more water to a lot more time, and you can get a lot more change and damage and destruction from a year-long global flood of catastrophic amounts of water than just 40 days and 40 nights, a little bit of raindrops. And so that is the scenario we're talking about when it comes to the flood. And Scripture is also very clear that this was a worldwide flood. It tells us all the high hills, all the mountains of earth were covered by water to a depth of at least 22 feet deep. We're talking about a lot of water on the whole globe. The surface, the face of the earth, all of it, it says, was covered by water. So that includes even right here in Ohio. That includes also where I live and work at the Grand Canyon. So when we look at the rocks and the layers of the Grand Canyon, do we see direct physical evidence for a worldwide big water event? Absolutely. These 4,000 feet of water-laid rocks that we see, we believe, are tremendous evidence of that flood event. And what do we find within these rocks that help us understand that? Well, when you look at that great unconformity, you can actually see there's a lot of rocks and like quartz and quartzite rocks that are kind of plucked up right at that erosional boundary layer. In fact, here's another picture you can see. You can actually see this very rock on our 4-day river trips. When you look at the rocks of the Grand Canyon, you guys see how nice and rounded that stone is? So this is a piece of quartzite, very strong, very hard rock, and we find lots and lots of rounded rocks and stones embedded right within the beginning of that Tapeats sandstone. Now you guys are a pretty clever bunch, as we already know from tonight. Where do you typically find round, smooth stones? In rivers and streams, right? Where did David go to find those smooth stones to slay Goliath? The Bible tells us he went down to the brook or to the stream. And why was that? Well, David was no geologist, but he was smart enough to know fast-moving water tumbles these rocks, knocking off the sharp edges, rounding them smooth. So we typically find round, smooth stones where we find fast-moving water, right? So when we examine this Tapeats sandstone, when we examine this big, massive mystery of geology, this big erosional boundary, and we find numerous rounded stones and rocks in there, what does that tell us scientifically, geologically, observationally about the way the Tapeats sandstone was deposited? Well, it tells us not only was it laid down by water, but it was laid down by fast-moving water. Exactly. Now, here's the real kicker, the real interesting thing. Not only do we find smooth stones embedded within that Tapeats sandstone, but what we also find down there are massive boulders that have been plucked up from rocks underneath and incorporated into their round and smooth. I've been over there, like I said, to Wisconsin, to Devil's Lake State Park, examining the same great unconformity like you see here. And there are washing machine-sized boulders that are round and smooth. We've seen boulders in there that are bigger than a bus. Huge, massive boulders. So we're not only talking about fast-moving water, but we're talking about a lot of fast-moving water, right? Now, I don't know what the definition exactly that Webster gives for a flood, but I think it has something to do with a lot of fast-moving water, correct? So, in other words, when we can take a look and we can see that this great unconformity gives us direct physical evidence of a lot of fast-moving water, well, friends, that is direct physical evidence of a flood. Now, geologists, again, who are puzzled by this, they would say, we don't know exactly what happened at this great unconformity, but there must have been a tremendous water event. That is in the secular published literature, because the evidence is undeniable. So we look at this great unconformity and we can see the great unconformity shows us direct physical evidence of a fast-moving water event. You might simply say flood. It's a lot shorter, simpler to say. Direct physical evidence of a flood. So let's continue looking at that exact same place. Let's look at that exact same boundary that we see there with that great unconformity. And again, when we take a look at the rocks and the geology, another really cool thing we find, another major mystery, and it happens to be at that exact same place where that Tapeats sandstone comes in, a big mystery. Well, didn't you just talk about a big mystery? Yes, but another big mystery. Not a big mystery necessarily of geology, but one of the largest mysteries of evolutionary biology. And that is known as the Cambrian explosion. Anybody ever heard of that before? Okay, so you've heard of the Cambrian explosion, sometimes called the Cambrian explosion of life, right? Now what this is, it's a worldwide, did he just say worldwide? Yeah, worldwide physical feature. And there's a kind of a pesky term if you don't want to believe in worldwide events. A worldwide physical feature, and when we examine these rocks at the exact same place, the exact same moment in time, we find an explosion within the fossil record. So we basically find underneath that the tilted angled layers that you see in the Grand Canyon, basically no fossils, no fossils, no fossils. All we typically find are simple single-cell organisms like cyanobacteria, things that we typically see today in calm and placid seas, stromatolites and things like that, but no real body fossils. So it's basically no fossils, no fossils, no fossils, no fossils, and then all of a sudden where you get to that Tapeats sandstone, the exact same place where we find massive erosion, a flood, and on the same way, on a worldwide scale, we see an explosion within that fossil record, like I said, that represents nearly every major phyla of life known to man instantaneously, without the evolutionary precursors leading up to it. It's basically nothing, 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 boom, everything. An explosion of highly developed, complex life. And it's a puzzle to geologists because they look at this explosion within the fossil record and they say, where did it come from? It's as if evolution had a magic leap forward. It came from nothing to everything. Well, they're puzzled by this because it goes opposite of the predicted model of evolution, which again says at the bottommost layers we should find simple single-cell organisms gradually, eventually working their way up through the fossil record, becoming more and more complex over time. We should see a nice, steady transition of evolutionary development. But guess what, friends? We do not. What we find basically is an explosion within that fossil record. And I find it fascinating that we find that explosion within the fossil record, again, on a worldwide scale, the explosion within the fossil record at the exact same place, the exact same moment in time that we happen to have this worldwide massive erosion. So that same place that we find that great unconformity, we find this explosion within the fossil record, this Cambrian explosion, like they say, the Cambrian explosion of life. But if you think about it, what are fossils? Are they living things or are they dead things? They were once living, now they're pretty dead, right? They're dead and in many cases been replaced by minerals. So really, if you think about what's happening, then if you think about if the flood was really true, like the Bible talks about, what we're seeing is not the Cambrian explosion of life, but rather an explosion of death, right? And that's exactly what we see. We had life that existed before that point. From creation until the flood, we have life that existed on the planet. But what we don't have until we get to the flood is a massive explosion of death and burial on a worldwide scale. So when you think about the mechanisms of the flood, when you think about the rock layers that were deposited by the flood, it gives us the perfect conditions for fossils to form. Now we look at this, and why do we believe that the fossil record, this explosion within the fossil record, is evidence of the flood? Well, because the flood provides those right conditions. You think about how fossils are made, and few people realize this, but we don't really have fossils forming today. Fossils typically are the result of a rapid burial, and rapid burials are oftentimes associated with big, catastrophic events. You know, few people realize this. You look at the layers of the Grand Canyon, and if you go up there, you might see a park sign that talks about some of these layers, and they might say things like, well, these fossils are the result of oceans moving across the landscape, across the continent. Somehow, the continent of North America was somehow pushed down, and the oceans somehow rose up, and the ocean sat on top of the land for millions of years. Things lived in the ocean, they died in the ocean, they slowly fell to the bottom of the ocean, and then over millions of years, sand grain by sand grain, particle by particle, they were slowly buried, and then the ocean retreated off the continent, and then it repeated that up and down process, they say, perhaps 17 different times across the North American continent. So they would say that's how these major layered packages of sediment got deposited. Now, I have a problem with that, because if that's how fossils are formed, and if the oceans produce fossils like that, we should probably find fossils in today's oceans, right? Well, few people realize this. We don't find fossils typically in today's oceans. We don't find things even fossilizing or turning into fossils in today's oceans typically. And why is that? Because that is not how fossils are formed. Fossilization requires rapid burial. Things that live and die in the ocean, what happens to them? They float, they bloat, they get picked apart by scavengers, right? They get eaten and consumed. Even entire whale carcasses that may sink to the bottom of the ocean floor, even down there, tremendous scavengers. There are crabs and crustaceans and hagfish and eels that consume even the very bones of whales very, very quickly. Things that die in the oceans today, they don't become fossils, they become food. Exactly. Now, we look at what it takes to create a fossil. For something to become fossilized, it needs to be rapidly buried by a pretty good amount of sediment so that it's kept out of reach of these scavengers and kept in an oxygen-free or anaerobic environment so it doesn't naturally decay and decompose. Now, those kind of conditions are not happening in the world today, which is why we don't find fossils forming in today's world. However, those exact processes, those exact conditions are exactly what we would see from a global flood. A tremendous amount of water, and not just water, but dirt and debris and sediment, all this stuff that's been eroded, all the material that's been eroded by tremendous water surging onto the continents, it's carrying all that dirt and debris, and it's sandwiching and blanketing forests and ecosystems. And what we see in the fossil record is an explosion within the fossil record, not an explosion of life, but an explosion of death. And it's as if a massive watery event suddenly happened on a worldwide scale. Add that up, pretty simple. Flood. So when we look at this, what we find here, not only geologically do we have evidence for this big flood, but even biologically, with this Cambrian explosion, we find direct evidence for a flood. You might even say only during a flood do we find the correct conditions for fossils to form. And so that's what we're looking at here, a massive catastrophic event. So when we look at this Tapete sandstone, we look at this one zone, it's my favorite area of the Grand Canyon to really talk about because to me it holds a huge key to what we see geologically. And it's really the beginning, that Tapete sandstone, again, that kind of yellowish layer you see a little below halfway down there. We see an explosion of erosion coinciding with this Cambrian explosion. Those two things go hand in hand at the same moment in time and on a worldwide scale. So if we can look at this layer, if we can look at this beginning, just this one rock layer, I'm not even talking about everything else. There's tremendous evidence in all the other rock layers. You know, we have only like an hour and a half tonight. We have a 4-hour tour, and even on a 4-hour tour, we can't cover everything. Even on a 7-day river trip, there's still some things we leave out. But tonight, you kind of get the fire hose version of flood geology. I know I'm throwing some big terms at you and speaking kind of quickly, but I'm really only focusing on one specific area. But even that one area of the Grand Canyon holds tremendous evidence for a flood. So when we can look at this rock layer, we can determine that this Tapete sandstone has been deposited by a flood, and we can see the beginning of this explosion of death. When we look at this Tapete sandstone, and we can determine that it was deposited again by a fast-moving worldwide water event, the next question we need to ask and answer is, what is the extent of these sedimentary rock layers? What is the extent of this Tapete sandstone? So the third little piece of evidence I want to share with you guys tonight, we talked about the great unconformity, geological erosion. We talked about the Cambrian explosion, an explosion within the fossil record. The third evidence really is the extent of these sedimentary layers. So if this Tapete sandstone was deposited by a flood, how far-reaching does that layer extend? Now, if I told you guys that we can trace this Tapete sandstone across the entirety of the Grand Canyon, that's 277 miles of a fast-moving water event, 277 miles wide of a flood, right? Now, I don't know about you. I know we got a lot of rain last night, didn't we? But I don't think it covered 277 miles flooding this whole landscape. But we look and see direct evidence because that Tapete sandstone covers the entirety of the Grand Canyon. You might agree, that's a pretty big flood, right? But it gets bigger than that, because that same Tapete sandstone you see there can be traced across the entire state of Arizona. Now, what kind of flood events do we see happening today that cover entire states? We don't see it like that, but it gets much bigger than that. And I kind of hinted to that before with telling you what I find right around here. This same layer of rock, this same Tapete sandstone, that yellowish, you see it, like I said, a little bit below halfway down there, that same layer of rock is not only traced across the entirety of the Grand Canyon, not only traced across the entire state of Arizona, that same layer of rock can be traced across the entire United States. This yellow shows you the distribution of that Tapete sandstone across the U.S. That layer of rock goes all the way through here. And where's the great state of Ohio? Did you guys know your house sits on top of Grand Canyon sediments? If you drill down, you're going to encounter the very same layer that you're going to go see at Grand Canyon. So you might as well just stay here and not leave your home because it's the same stuff, right? Well, there we happen to be able to see it. So we even have the ability to see the Tapete sandstone, but around here it's kind of hard to get to because it's down, pretty far down. But they've actually done core sample drilling from here, and in some of the geological museums here in Ohio, they do have the Tapete sandstone. In fact, Dr. John Whitmore, the head of geology at Cedarville, he's gone and seen them. He's looking at this thing, oh my goodness, this is what we see and study at the Grand Canyon, and it's right here in my house. So we're talking about a continent-wide, fast-moving water event. Again, you might simply say, a flood. But wait, there's more, right? Because not only can we trace the Tapete sandstone across the United States, this layer of rock goes all the way up into Canada, goes all the way to Greenland, and in fact, you can trace the very same Tapete sandstone equivalent all the way across North Africa, in through southern Israel. Anybody been to Israel? Anybody been to southern Israel, Timnah area? You can see the exact same great unconformity at Timnah, at the Pillars of Solomon there. You can see the exact same Tapete sandstone equivalent. It goes through southern Israel, it goes through southern Jordan. And anybody ever been to Jordan? Nobody? Nobody yet, let's say that. Anybody ever been to Petra? Anybody ever studied anything about archaeology in the Middle East? You may have seen things of Petra. Petra is a sandstone city carved out by the Nabateans about 2,000 years ago, we estimate. And it's been carved into the exact same Tapete sandstone equivalent. Now, you may not have seen it yet if you've traveled there, but anybody seen Indiana Jones and the Last Crusade? Well, at the end of that movie where they're going to get the Holy Grail, that part might be fake and all, but the stone temple they go into is a real-life location, and it is carved into the very same Tapete sandstone. It goes right through there, and recent studies that I was just hearing about, they've traced the same Tapete sandstone equivalent all the way to Eastern Asia. So again, when you're talking about the same dirt from there to here, all the way to China, that same dirt must have had an event to carry it across the world. And when that event has been shown to be a fast-moving water event across multiple continents, I don't know how much more physical scientific evidence you need to understand there really was a worldwide fast-moving water event Again, much simpler to say a flood. So when you look at this, it's very hard to even tell the difference between Grand Canyon and where all the other rock layers are. Here's a fantastic picture of the bottom of the Grand Canyon from Blacktail Canyon, and a picture of the same geology equivalent in southern Israel. Now look at the geological similarities. In fact, I've shown this picture of Israel to other people. They said, oh, where is that in the Grand Canyon? Geologists look at this and recognize it's Grand Canyon, right? No, it's southern Israel. It's the same rocks, and that's why geologists are saying, oh, this must be a place in Grand Canyon, because I'm so familiar with the rocks and geology. And you can say, actually, it's over there in Israel. Oh, well, it must be a similar looking layer then. Or it's the exact same layer. And so geologists have actually done the chemical and physical fingerprinting of the geology and realized it is the same continuous layer. And again, that's only one of these layers we've been talking about tonight. But when you look at the extent of these sedimentary layers, I believe it gives us tremendous evidence for this flood geology like we're talking about. Those three different evidences that we see, first of all, massive worldwide erosion coinciding with massive worldwide explosion within the fossil record, and then this material distributed across the world. Three, what I kind of say, pretty solid, rock solid evidences for a global flood, and things we like to point out on our trips and tours, along with a whole bunch of other stuff that we just don't even have time for tonight. But one of the things we want to talk about, of course, we talked about the layers, how they were deposited, and then we're going to talk a little bit about the carving of this here Grand Canyon. That's kind of the next phase, like we talked about. First of all, you got to make those layers, then you bake those layers, then you get a chance to carve out the Grand Canyon. So how do we see the Grand Canyon formed? Well, there have been a lot of different theories and ideas that have been proposed about Grand Canyon formation. Going all the way back to the early days in the 1800s, they said things like, looking at the Grand Canyon, it appears that it was carved out rapidly and catastrophically by a lot of water. Guys like Dr. John Newberry, early geologist, came out and he studied this whole area and he realized this looks like a massive amount of water carved through here. So believe it or not, in geology, in science, that was one of the first ideas that were proposed. And then other ideas came about. Maybe this is a result of a big earthquake. Maybe there was a big split in the land and the earth split open and it's a giant fault line fracture. So that was thought and taught for a little bit. And then another idea came about. Maybe, given enough time, we could say that Colorado River way far down there slowly carved through and created this here Grand Canyon. So then that was another idea that was proposed, and that idea, of course, has gained hold, and a lot of the reason for that is it's an idea that incorporates millions and millions of years in the making. So, in the late 1800s, if you wanted to be a so-called real geologist and scientist, you had to jump on this new bandwagon that was being taught in science, and that was millions of years of slow gradualism being incorporated in every area of science. So guys like Charles Darwin, of course, he utilized millions of years in the making with his publishing of The Origin of Species in 1854, which kind of brought about an idea that millions of years applied to biology would give a slow, gradual rise to the variety of life we see on the planet. But Darwin didn't even come up with that idea of millions of years. He actually borrowed that idea from many other people, including another Charles, a guy named Charles Lyell, who back in the 1830s published a series of 3 books called The Principles of Geology. And Charles Lyell is oftentimes looked at as the father of modern-day geology, and he taught millions of years in the making of slow gradualism, a process known as uniformitarianism. Basically meaning slow, gradual, uniform change, given enough time, could add up to really big features. So Charles Lyell would say things like, the present is the key to the past. In other words, if you want to understand what happened in Earth's ancient past, just look at today's present world. Everything we see happening in the world today is the same as it's always been since the beginning of time. So if you want to understand what has happened in Earth's ancient past, just look at today's processes. But as someone who believes the Bible, God's Word, to be true, I would say it's the exact opposite that's the case. It's not the present world that we live in today that's the key to understanding the past. Rather, it's understanding the past that is the key to understanding the present. Again, if you want to understand why we have the world we have today and how we got here, you need to understand what has happened in the past. Again, God's Word, the Bible, gives us a clue to some of those things that we see that have happened in the past. You know, like a really big flood event. So when we look at this idea of millions of years became very popular in science, and so that was applied to the science of the day. And it's remained very popular to this very present day. And over time, the idea of millions of years in the making by the slow carving Colorado River forming the Grand Canyon has become the leading theory. However, there's another great theory that we've been talking about for decades now, but a theory growing among the everyday scientific geological community, and that is, looking at this Grand Canyon, maybe that river couldn't cut it. You might say that theory just doesn't hold enough water. But what does hold water is a lot of water. So you can actually see there are geologists in Arizona that are talking about this, teaching at our universities, teaching that the Colorado River carving idea may not exactly hold up, may not exactly work. In fact, you can see it on programs that's like out on Discovery or National Geographic Channel talking about Grand Canyon formation and a growing theory, something we've actually been sharing for a long time, and things that were published by guys like Dr. John Douglas, who back in 2000 published his, we call lake spillover or breach dam theory for Grand Canyon formation, and has been growing steadily ever since, has to do with a lot of water spilling through the Grand Canyon and rapidly carving it very, very quickly, which actually goes back even way before John Douglas. In 1994, Dr. Steve Austin published this with Creation Research, ICR, Institute for Creation Research. He published a book about Grand Canyon Monument to Catastrophe, and in there he talks about it. And this theory goes even before then, back to the 1800s. And what we see here, this theory has never died out, and in fact, lately it's actually growing in resurgence. Because with this great, fantastic tool we have nowadays called satellite imagery. And with satellite pictures, it really helps us get the big picture view of what's going on at the Grand Canyon. And when you use satellite imagery, you can see very, very clearly in the landscape a shoreline environment. You can see a bowl-shaped depression. You can see the terraces where the shore was at. And in fact, a research paper that I just co-published with Dr. Stephen Austin last week, we presented it, or no, this week. Yeah, still this week. Earlier this week, on Monday, we presented this paper about this brand new discoveries, these shoreline terrace deposits for this massive lake system we're talking about. And so even today, we are still doing ongoing science and research in the field. So you've seen this picture long enough and you're saying, okay, I can see this picture, you kind of see the little squiggle line down below, that's where Grand Canyon is. Now, when you're talking about a lake, what are you talking about? Because when I say lake, you're thinking small lake. Well, actually, you guys might be thinking big lake, because you do have a pretty great lake not too far north of here, right? And that's what we're talking about, a huge amount of water. So looking at the landscape, we can see there was a huge, massive body of water. In fact, this doesn't even show the full extent of it. But you can see down near the bottom, the little black little squiggle line, that's the Grand Canyon. To the right of it, and there's another lake off the map to the north called Lake Uinta, and there's part of a lake coming down south here that's still not quite fully on there. We're talking about a massive, huge lake system. And you can see as I go back and forth, you can see the outline of where this lake used to be. And when you look at it with satellite imagery, you can see a massive, huge body of water. Now this shows you what this lake system looked like in the middle of what we call the Colorado Plateau. So what I've done here is I've taken the yellow color, that shows you the outline of the Colorado Plateau. And in the middle of this plateau, you can see where this big, massive lake system was at. Now, the Colorado Plateau is not exactly flat on top like most plateaus. The Colorado Plateau is actually shaped like a giant bowl. It has a big rim, a perimeter of mountains all around it. So if you think about it, if you pour water into a bowl, where is that water going to collect? In the bottom, right? It's going to stay there. So if you continue pouring water into that bowl, what happens when you fill that bowl beyond capacity? It spills over. So if you take that little example and you scale it up to a massive, huge geological size, and you have a tremendous amount of water flowing into it, and here's what we see with the Colorado Plateau. This Colorado Plateau, shaped like a giant bowl, has numerous rivers and streams flowing into the middle of it, right? You look at the Colorado Plateau today, though, and there is only one exit route of any good size that water can drain off of that bowl. Guess what that one exit route, that one drainage, that one crack in the side of the bowl, guess what that happens to be? The Grand Canyon. So you look at this and realize, well, wait a minute, we have a Grand Canyon, it's the only real drainage in the plateau, yet we know there used to be really large lakes. Geologists have put two and two together and realized you cannot have a bowl of huge amount of water and a Grand Canyon at the same time, because you can't fill a bowl of water if you already have a giant crack in the side of it. Now, when we're talking about this huge lake, we're talking about a massive lake on the landscape. We are talking about here, as you see in this animation that I put together, you can see a tremendous amount of water. Now look at the size of all this water compared to the size of the Great Lakes. Yeah, it's kind of roughly equivalent, actually. Some upward estimates for the volume of water, anywhere between 5,000 and 6,000 cubic miles that were held right here in the middle of this Colorado Plateau. And as we tilt down here, you can see, as we're kind of going to zoom across this lake system, this water, they estimate, in places, was up to 2,000 feet deep. That's a lot of water. More like an inland sea, actually. So the basin of this lake system, this is Hopi Lake we're flying over right there, the basin of this lake system was right around 4,200 feet that we see today. Yet the shoreline perimeters that you see of this lake, right around 6,600 feet. So in other words, from the bottom of the lake to the top of the lake, we're talking about over 2,000 feet, perhaps, in some places. Again, estimates between 5,000 and 6,000 cubic miles of water, which actually is roughly equivalent to all 5 Great Lakes combined. I think the volume of the Great Lakes right around 5,500 cubic miles. We're talking about right around the same amount. So begin to think about it. If you had the volume of water of all 5 Great Lakes, and you poured that water through one single exit route, you better believe you're going to get a canyon carved pretty quickly. Tremendous amount of water. So this is what geologists are starting to look at. And my area of focus with Dr. Steve Austin has been just this part of the lake, the lower section, called Hopi Lake, or sometimes called Lake Bittahoche. And the reason that I studied this is because it's right next to my house. If you look kind of in the middle there, you can see Flagstaff, kind of right in that section right there, right along 89. So that's where we live, and then we drive up to go see the Grand Canyon. But this area, this body of water, Hopi Lake, has actually been the talk of a presentation we gave last year at the Creation Geology Society conference. And again, what we presented just this week earlier, talking about looking at the physical evidence for this massive lake system. And let me tell you guys, that physical evidence is absolutely there. And so geologists have been asking, well, show us, the smoking gun, show us the geology, show us the shorelines of this lake. And it's out there. In fact, the paper that we just published on Monday and presented on Monday will be released with the 2023 International Conference on Creationism, ICC. You can read more about that paper when it comes out here, hopefully in the next few months. Anyhow, again, we're not the first ones to identify this. It's going back all the way to the 1800s, again, with guys like John S. Newberry. And Newberry, looking at this whole area, he entered the Grand Canyon through a section called Diamond Creek, and he explored the lower end of the Grand Canyon. He walked completely through this, we call the Bittahoche Basin, which is kind of this lake basin you see there. The bottom of the lake basin is the Bittahoche Basin. He measured the thickness of it. He looked at this whole area. He recognized that it was indeed an ancient lake basin. He published his ideas about Grand Canyon lake spillover all the way back in the year 1861. So guys, this is not a new area of science, nor is this just an area of, creationists trying to make up stuff. This is something that's been documented in the scientific community and talked about for quite a long time. So John Newberry talked about this all the way back in about 1858, and it was continued to be talked about in 1936 when the lake itself was named Hopi Lake by a guy named Howell Williams. And as you continue on, the name Bittahoche, which is kind of a Navajo word for this area where we find the lake shore and the lake sediment, was talked about in the 80s and continues to be talked about today. So when you go and examine where this lake used to be at, you can see freshwater mud bottom deposit. This shows you right here the Bittahoche Formation. Kind of got the lower, middle, and upper members of that Bittahoche Formation. And a lot of this Bittahoche Formation is actually found in the form of greenish-looking clays, which are pretty important to understand, because greenish lake clays indicate deep water environments in which they're formed. In other words, this is a really deep, big lake We find within there fish fossils, freshwater fish fossils, so there's a freshwater lake system. We find freshwater mollusks. We find other animals living around that lake. We find things like beaver fossils, and there are saber-toothed cat fossils, and there are mastodon fossils, and there are tundra swan fossils. This is a lake system, a massive, huge lake that extended after the flood into the Ice Age. And so we believe that absolutely there was an Ice Age. You guys have really good evidence of that right around here. It's all on the rocks. There really was an Ice Age, lasting anywhere, we believe, somewhere maybe up to 700 to 1,000 years after the flood. And the Ice Age not only was here, but we had some pretty cold environments where we live in northern Arizona. Enough that we find fossil ice casts on the shoreline of this Hopi Lake. In other words, it was cold enough to freeze parts of that lake. And we had tundra swans that walked around. We actually have tundra swan tracks and their fossils. Now, where did tundra swans typically live? It's in the name. Tundra, which is not found in Arizona typically. So we have direct evidence that this big, massive freshwater lake extended well into the Ice Age. And this is when we believe that the Grand Canyon was formed, sometime probably near the end of the Ice Age, when these glaciers in the upper Colorado River Basin were melting back, and a tremendous amount of water was flowing into this lake, and it rose quickly and rapidly, and either topped over its border by pure spillover, or maybe an earthquake or some kind of trigger effect triggered a breach. Now what happens is when this breach happens, this water begins to spill over, and once it spills over, you don't stop it. Because if you have water spilling over an earthen dam, it's a really, really bad thing, right? Because even a little bit of water going over starts a little bit of erosion. Well, a little bit of erosion means more water can start to spill over, right? More water means more erosion. More erosion means more water. More water, more erosion, more erosion, more water. Pretty soon you end up with a catastrophic exponential runaway process that would drain this entire 5,000 to 6,000 cubic miles of water. And as you drain off all this water, it's going to carve an escape route. Again, you put two and two together and you realize the draining of this lake system is what carved its escape route that we call the Grand Canyon. Now, other evidence that we see around there, we find freshwater, we call tufa deposits. Tufa is kind of like a redeposited calcium carbonate limestone. It's similar to like travertine, and there's pretty good evidence. In fact, this was just presented. I presented this evidence at a poster presentation at the conference. In fact, this picture was part of it. And you can see what we call these kind of banded stromatolitic tufa, where you can see that there's shoreline deposits. Again, something formed in a freshwater environment at the shoreline from evaporate deposits. It has all these laminated bands in there. It's pretty interesting to see. And again, other fossils that we find in the area, like I mentioned, the tundra swan fossils, which, typically live way up there in the tundra. We find their fossils, we find the ice caps, we find all kinds of stuff. So tremendous evidence that, yes, there really was a big lake. And here's the really cool thing. The paper that Steve and I just published with a couple other contributing authors that was just talked about and released this Monday has direct physical evidence, we believe, of lakeshore terraces, lake shorelines, basically. And this is what you see when there's a lake that rises up and the waves go back and forth, and they kind of cut these terrace banks in the side. And for many, many years, geologists have been saying, well, if this lake really existed like you say, show us the terraces, show us where the lake was at. Show us a smoking gun of this lake. And 2 years ago, I think I found it, which is the topic of this paper. And if you see in this video here, I'm going to show you guys. It's kind of hard to see here, but you can see kind of these lines going across the landscape. Can you guys see that? You see the lines going. This is actually working its way up a ridge line. So there's a ridge, and it's going up a slope. So as the water in a lake is rising up and up and up and up, it matches the elevation that has already been predicted. So here's a prediction of science, a prediction like scientists do. They make predictions, they test and repeat and find out that the predictions hold up. This was a prediction of science all the way back in the 1980s that this lake rose up to right around 5,800 feet. Well, when I went out about a year and a half ago to study this and try to find this evidence, guess what I found? Right at 5,800 feet, just about 5,736 where that is, and going all the way up to the top here to right just about 5,800 feet, you can see evidence of these shoreline terraces. And so it goes up at an angle. This shows you like an elevation map. This ridge-line slope is one area that we focused on in our paper. And from the air, if you want to take a look at it, it looks like this. This is an aerial drone shots that I took looking out there. So you can see these kind of parallel ridges in the landscape, right? And if you've ever seen what a lake shore looks like, especially places where a lake used to be, like Lake Bonneville, or going all the way up to Lake Missoula up in the Channel Scablands area of eastern Washington, you can see where lakes used to be, you can find direct evidence of a shoreline terraces. And so this is what we're seeing, these kind of parallel lines still left behind on the landscape that is now complete dry desert. Yet when this lake was here, it left behind these shorelines. So the whole paper that we just presented on Monday at the conference has to do with the smoking gun of Hopi Lake being out there. So again, you can read all the technical side of that in this paper. It should be published pretty soon, and Dr. Steve Austin has done a lot of work in writing up the technical side of it and answering a lot of questions on that whole thing. But yeah, I think it's exciting. Again, it's exciting to be alive because science and geology is still being done. We're still investigating the landscape. We're investigating God's creation. We're investigating things that we see. Now, when you look at this massive, huge lake system, we can see the lake was there, and then it was as if it just disappeared. The water was there, and then it was gone. The only place the water could go, the only exit route, the only drainage, the Grand Canyon, again, you can't have a bowl of water 2,000 feet deep if you already have a giant crack in the side of it. And we know the lake that was there, we know the lake that was there didn't simply dry up over a long, long period of time. Some people say, well, could the lake have just sat there but eventually just dried up? No, because we know what dried up lakes look like, don't we? Anybody ever been to the Great Lakes? Anybody ever heard of, Lake Bonneville, the Bonneville Salt Flats? Dried up, evaporated lakes leave behind huge salt and mineral deposits. So we know this lake didn't dry up because when you examine the landscape, no major salt mineral deposits. The water was there, and then it was gone. It drained through and carved the Grand Canyon as its escape route. So what did that look like? Well, here's kind of a little picture that you might see here. On the left-hand side, you can see maybe where the lake shore used to go up against. On the right-hand side, you can see the main section of the Grand Canyon. That dark green band going across there on the south shows you the Coconino Plateau. The north rim side of it's the Kaibab Plateau. This big strip of land in the middle is a big rise. It's like a big wall. And it actually comes up from the landscape about 3,000 feet to form what we call the East Kaibab Monocline. It's a big uplifted landform. And this is like a natural earthen dam. Well, when the water starts to spill over, it comes through very, very rapidly, catastrophically spilling through there. A big, massive lake system coming through the Grand Canyon very, very quickly. Here's another cool satellite footage film thing that I put together. Kind of shows you where the drainage areas are. When they come into here, you see where these lakes spill in here. It's going to circle around where Hopi Lake spilled into here. This is the Little Colorado River Gorge up in the top section, and it dumped into the main Grand Canyon channel. So when we look at this, what we're looking at is a lot of water in a little bit of time that did this, not a long time and a little bit of water. So looking at this whole scenario, what we would say is there is a canyon not because there's a river down below, but there's a river down below because there is a Grand Canyon. The canyon came first, and the Colorado River that flows through it to this day just takes advantage of the low course of action flowing through there. Water seeks, a course going out, the lowest point that it can possibly take. And so that's what we're seeing, a canyon that came first, a river that came second, and it's actually very similar to another thing that we've seen within our own lifetimes. A great example to study, a great example to look at, of course, is Mount St. Helens, right? Now, some of you guys remember that. May 18th of 1980, Mount St. Helens erupted, right? Now, a lot of you guys, who remembers the eruption of Mount St. Helens? Raise your hands. Yeah, most people in the room. So that big eruption took place, and a lot of people remember that. But who remembers the smaller eruption that took place not long after that, like 1982? Like, oh, there was a smaller one? We got one guy. Way to go. Smaller eruption. Well, it actually had some smaller eruptions even after the major eruption. And what happened was a smaller eruption melted a bunch of snow and ice that were up at the top of that mountain. And that snow and ice melted and came rushing down the front face of Mount St. Helens. All that water and mud came carving down through, and it carved a canyon called Engineers Canyon. It carved that canyon about 100 to 120 feet deep, and it carved that entire canyon 120 feet deep in only 12 hours of time. Overnight, just like that. They walked through it, and there's like no canyon, valley floor. They walked up the next day, an entire canyon system, not just a single canyon, but side canyons, multiple side canyons, and U-shaped amphitheaters, and all kinds of physical features that look just like the Grand Canyon. In fact, they call it the Grand Canyon. They call it the Little Grand Canyon of Mount St. Helens. Not only because it physically looks like the Grand Canyon, but because it has all these features, including a little stream flowing through it. Now, if you didn't know anything about Mount St. Helens, if you didn't know anything about Engineers Canyon, and you were walking through that canyon, you would see a stream flowing at your feet, and you would see canyon walls 120 feet high around you, and you would probably say to yourself, I wonder how long it's taken for this little stream to carve out this canyon I'm standing in. It must have taken hundreds of thousands or millions of years, right? Because we're taught, and we oftentimes think, rivers and streams carve canyons. But if you thought that about Engineers Canyon, you'd be completely wrong. That canyon was not carved by that stream. The canyon came first, the stream came second. The stream just continues to flow out of there. Likewise, many people have stood at the rim of the Grand Canyon, and they have said, oh, there's a canyon here and a little stream down below. And if you've ever seen the Grand Canyon, this canyon is up to 18 miles wide, yet that river down there only averages 300 feet wide. It's vastly oversized for that Colorado River, especially considering geologists don't believe the Colorado River got much bigger than what we see today. So how do you have a river carving an 18-mile wide canyon? It just doesn't add up. How do you have side canyons, massive, huge side canyons that are huge and deep and wide that are completely dry with no water source flowing through them? It doesn't add up. Why do we have a big, massive lake system that we have evidence to the east of here? And where did the water go? We start to look at the Colorado River theory again. That theory doesn't hold a lot of water. But what does is a lot of water, massive, huge amount of water spilling through there. Again, like you see with Engineers Canyon, I would say the same thing for the Grand Canyon. There is a river there that came after the canyon was opened up. This is a catastrophic event that carved the Grand Canyon, and the river takes advantage of that. So why does that matter? What is the significance of any of the stuff we've been talking about tonight? Who cares if the Grand Canyon was formed by a river or by a big lake? Well, again, going back to what I started with, the Grand Canyon is oftentimes used as a picture and a evidence of millions of years, right? They would say, you crazy creationists, you Christians that believe the Bible and believe the earth is between 6,000 and 10,000 years old, that can't possibly be true because we know things like the Grand Canyon took at least 6 million years to be formed by that Colorado River. Explain that. Well, I just did. And in case they missed it, they can watch it on YouTube. They can come out on the tour with us. They can come see it for themselves, and it's blatantly obvious that river could not cut it. You look at what did. This power of this lake spilling through here can carve this canyon very, very quickly in a matter of weeks to months. A lot of water in a little bit of time. That erases the millions of years in the making for the Grand Canyon. And again, you look at the timeline of this, and it matches perfectly with what we see in Scripture. A global flood that deposited all these layers of sediment, and then after it was deposited, a massive, huge lake system, perhaps 700 to even 1,000 years after the flood in Noah's day, as these layers were beginning to kind of firm up and consolidate, and as this lake system is rising up, and as the Betahoche Formation, the lake basin is filling in, then this thing breached and carved the Grand Canyon very, very quickly, right within the timeline of what we see in Scripture. So again, we see that there is power in the rocks and the geology, and again, you might even say the rocks cry out. They are a testimony of God's word being true. And you can put your faith and hope and trust, and you can rely upon that very, very thing. And the biggest thing, the best thing is, tonight we've talked about what we have. We've talked about why we have it. But really the most important thing is the significance of what does it mean to us. When I stand at the rim of the Grand Canyon, I am in awe of our Creator God. And thousands of people that come through our ministry every year can't stand there and be unmoved. When you see that amount of power, when you see that on display, all you can simply do when standing there is look out over that canyon and say to God, thank you. Thank you for this gift that you have given us. And when you think about it, that's what the canyon really is. It is a powerful gift from our loving Heavenly Father. You think about it, the canyon, and I tell people on our tours, the Grand Canyon, this is the result of judgment and wrath. This is the wrath of God poured out upon the earth because of the sin of mankind. The layers of the canyon that we're seeing every single day out there are layers that were deposited during the flood. We're literally standing on top of a massive watery graveyard. Right here tonight, this building and your homes sit on top of a worldwide watery graveyard of destruction. The Grand Canyon, those layers are made up of that same graveyard of destruction. Yet even in that, even in destruction, we see amazing beauty, don't we? Because God has a business of making beauty from ashes. Because God is all about the business of redemption and of restoration. God could have destroyed this world and left it a complete, utter wasteland, right? It was our sin that brought about the flood and the judgment. God could have destroyed the world and said, fine, have it your way. But I am so thankful to God that we do not have it our way. We have it His way. And His way is a heart of redemption, of restoration, of calling us and drawing us back to Himself. And I believe in many ways that God has purposely given us the Grand Canyon as a monument to that destruction and a monument to the love that He carries for us. Because even in destruction, even in correction, God has brought about something incredibly beautiful, something that draws people from around the planet. 5 to 6 million people every year come to see and to stare at this place. And our hope and prayer every day is that God will use that canyon somehow in speaking to people's hearts and to people's minds and in drawing people to Himself. We can do our part at the Grand Canyon with Canyon Ministries and being a voice in the wilderness, if you will, a literal, real wilderness, but only God can draw the heart of a sinner to Himself. We can be that voice. We can share that gospel message. So I encourage you guys, I would ask you guys to share the message that you've heard tonight. And absolutely come out and hang out and visit us and see us, but you don't even have to go out there. You've heard something tonight about the Grand Canyon that is a testimony, and so you can add your voice to ours as it echoes the name of Jesus from that Grand Canyon into the four corners of the earth. You can add your voice to ours with those rocks of the canyon that cry out His name. You can also share that testimony because you've heard and gained something even tonight. You can talk about the Tapete Sandstone because it's right underneath us tonight. But the message of the Grand Canyon goes well beyond a message of destruction and of death and burial. It's a message of beauty from that event. It's a message of God's love, of His mercy, of His patience, of all of that combined. And even in that, God is a God of redemption, of restoration, a heart who redeems us and draws us back to Himself. And so I thank you guys tonight for spending some time and learning a little bit about my home and a place that I love near and dear to my heart. Boy, I wouldn't be there doing this for 13 years, 14 years now, if I didn't love this place. And it never gets old to me. People ask me sometimes, you ever get tired of seeing this place? And all I have to do is show them a picture or point to it. I'm like, no. Have you seen this place? And I spent nearly 1,000 tour days now with folks at the Grand Canyon, and never gets old. Well over 30 trips in the Grand Canyon, never gets old. Rafting through there for hundreds of days, never gets old. And you know why? Not just because of the rocks and the beauty of the landscape, but because of the beauty of the one who made it. It never gets old to me because He is new every day, right? And so the Grand Canyon and God's gifts to us every day are brand new. Amen? Amen. Well, if you guys have any questions, now's the time we're going to switch gears real quick. And so I know I've talked quite a bit to you guys. I know I kind of do a whirlwind jumping through a lot of different things, but do we have time for questions still? Fantastic. So if you guys have any questions, and I could spend all night with you guys, I'll stay here as long as you want to. I don't go to bed usually until midnight every day, so if you want to be hanging out, we can do that. But if you do have a question, feel free to raise your hand and speak up so everyone else in the room can maybe hear you too. And if not, I'll try to repeat that. So questions?
Yeah, I'm just curious, are you sensing a shift
I think so. I think we are seeing a shift in the scientific community, applying things that we see in known examples, like Missoula flood, which we believe was a massive, huge lake up in eastern Washington into Montana during the Ice Age, held in place by a big ice dam, and that breached, and it scoured out what we call the channeled scablands, and in fact, most geologists believe it carved out the Columbia River Gorge just like that, as all this water moved across the landscape and dumped into the Pacific Ocean. And so we're seeing a massive wasteland and tremendous physical evidences of a big lake and what it can do when it drains. And so geologists around the world agree to that. And so they're looking at examples like the Missoula Lake or Bonneville Lake, which is kind of the leftover remnants now, or the Great Salt Lake, and other places. And they're looking big lake, big catastrophe, big feature. Big water, big catastrophe, big feature. They're looking at it and they're realizing the more you look around, the more that big features seem to be tied in with big catastrophic events. So why not the Grand Canyon? And that is where I personally know geologists, I know park rangers up there, I also know other tour guides that are not Christian tour guides, creationists, that are also looking and saying, this actually makes a lot more sense than what we've been looking at. It explains so many more questions, and truthfully, it doesn't require a global flood. Now, those guys who believe in this lake spillover carving the Grand Canyon are not going to always believe in the same timeline. They're not even going to believe that the flood deposited the layers. They still may say the layers got here over millions of years, but the speed and mechanism by which you can carve the Grand Canyon does not require the millions of years in the making. So they would look at that very similar to what we've been talking about, with some subtle differences here and there. But I think science and geology, they've been asking the question of Grand Canyon formation for over 150 years, and they're still no closer using the models that have been most popular, so they're now going back to the drawing board. And what they're coming up with is catastrophe, catastrophe, catastrophe. Look at the Grand Canyon, catastrophe. So I think, yeah, I would say the scientific community in general is reanalyzing things, and many are coming to a new conclusion. Again, many of our geologists and people I know personally that live and work in Arizona are going to that same catastrophic perspective, perhaps. It's a great question. Other questions? Bronlyn.
So I just want to clarify two things in my brain. The first thing was the lake. So you're talking it could be 700 to 1,000 years after the flood. The idea that the lake is the flood itself, when it receded, filled that basin. Is that correct? Is that kind of where we get the lake system there?
I'm glad you asked that question, because if you have that question, a lot of other people probably have it too. So the lake that we see here, no, we don't believe that the receding floodwaters filled the lake. And that's a great question. In fact, we used to maybe think that. And it would make sense that, if the floodwater receded off the continents, they would leave behind puddles and pockets of water all over the planet, right? And in fact, we used to say that, and we used to kind of think that maybe this is where the lake water came from. But in our ongoing scientific research and field work, we've actually determined this was a freshwater body. The flood would actually have been salt water. This is coming from the oceans. And so what we see here in this lake system here, much like you see with the Great Lakes, this is a massive body of fresh water trapped in the interior and created by the Colorado River system flowing into there. So what we see is probably not evidence of salt water, which would have drained off the continents, but something that continued to rise and fill for the next few hundred to maybe 1,000 years after the flood. So the flood in Noah's day, we believe, laid down the layers. Those layers begin to sit there and firm up, and then about 1,000 years later, as this lake system off to the east is rising up, then that lake system rose up, spilled through the layers, and carved it out. So it's like a two-part event. The big flood, capital F flood, in Noah's day, and then a smaller regional local flood that carved the canyon out. Does that help clarify that? Good. That's a great question, and everybody asked that question too. So I'm glad you asked it, if anybody else needs clarification on it. And so the evidence we see, it's a freshwater lake system. And so that's actually in the last 3 years have been something that's come to light when, again, we try to do real science, as scientists do. We go and examine the evidence. And the evidence shows us there was a freshwater lake. Freshwater fossils, freshwater sediment, freshwater lake system. So that probably means it wasn't left behind from the flood. Great question. Yeah, so so an unconformity, there are lots of unconformities. Even at the Grand Canyon, we have multiple unconformities. And what they see as an unconformity typically represents an erosional boundary. And so in standard geology, they believe that that boundary also represents a tremendous amount of missing time. So when you look at the rocks, it's between these layers actually where they insert the millions of years typically. And it's missing time in between these layers. You know, we see evidence that some of these layers were all deposited in one package. So if this whole, like Tapete sandstone was deposited in one go, where do you fit the millions of years? Well, they fit it in between the layers. And so, for example, in the Great Unconformity, when you look at that, between the basement rock you see down here, between the crystalline basement rock kind of going tilted or vertical here, and the layer going horizontal, most geologists would say we are missing 1.2 billion years of Earth's geological past. Now, I didn't say million, but billion. They say we're missing 1.2 billion years of Earth's geological past and Earth's history. And so they say that's what's an unconformity. It doesn't conform to the layers below. So the tilted angled rocks or the shearing or the, you know, they call it also non-conformities, unconformities, disconformities are all terms that kind of tie in with there. Depending on how we find it, they use different words. But what we see here is that there's an erosional boundary. There's not a steady sequence within the rocks. So they say it's an unconformity. The rocks do not conform. They don't match up. And so multiple unconformities are found around the world. This one, though, again, is called the Great Unconformity because it's a recognized unconformity worldwide. And this we see would be the beginning of the flood in Noah's day, when the waters from the oceans are now surging onto the continents. Tremendous amounts of water. We see evidence within the rocks that currents of water were traveling across the globe perhaps over 100 miles an hour. We're talking about huge, massive currents. Tsunami-like waves that are slamming into the continents. The continents themselves at this point, we believe, were broken apart. And they moved rapidly and violently. In some cases, these continents are colliding together. And as they collide together, they're buckling and forcing up huge, major mountain ranges. So that during the flood, it's not simply just a mere water event. No, this is a huge, catastrophic tectonic event. We would have volcanoes and earthquakes going off around the planet. We'd have entire mountains being formed and valleys ripped open. And guess what? Scripture tells us that exact thing too. Psalm 104 talks about the flood. Psalm 104 verse 8 tells us that mountains rose and valleys sank to the levels that God decreed. So again, we're not just talking about a mere water event, but a catastrophic erosional event, tectonic event. And so this great unconformity is a massive erosional boundary. And again, the reason they would believe the millions to billions of years of missing time is because we see a tremendous amount of erosion there, and they see basically no fossils to an explosion within the fossil record. And so using the assumption of uniformitarianism, using the assumption of slow, gradual processes, that's where they would insert that missing time. But that's only one unconformity. There are multiple other ones that represent millions of years of time missing as well. But that, again, the great unconformity, because it's a worldwide physical feature. So it's a long answer to a great question. Yep.
It was all washed off during the runoff of the flood stage.
Right.
Have we made progress in terms of identifying where all that material is?
So there was sediment above the Grand Canyon, absolutely. So when you look at the rim of the Grand Canyon, you know, looking at the Grand Canyon, you've got about 6,000 feet of the Grand Canyon, 4,000 feet of the horizontal sedimentary layers we believe deposited during the flood, but we're actually missing a tremendous amount of rock layers too. When you're standing on the rim of the Grand Canyon looking down below there, you're seeing what's left behind, but believe it or not, we're actually missing another perhaps 6,000 to 8,000 feet of sediment on top of the Grand Canyon that's been stripped away. So this material has been removed. We call that the Grand Staircase. Those are the layers we see when you go up to Utah. We can actually see more layers that are stacked up on top of the Grand Canyon sediment. And we believe that they were stripped away and removed when the floodwaters in Noah's day retreated off the continents in a process known as sheet erosion. So it's like when you go to the beach, right? You see a wave rises up and it carries with it some sand and seashells and debris. It pushes it up onto the shore. But as that wave retreats and draws down, it drags with it a tremendous amount of sand and seashells and debris and kind of pulls it all back down. So imagine that process, but on a global scale. Water rising up, covering the landscape, tremendous erosion, and as all this soft mud, unconsolidated sediment is up there, as the waters begin to retreat from day 150 until the end of the year-long flood, as those waters are pulling off the continents, it's removing a bunch of stuff that it just deposited that's still soft and squishy stuff, pulling it right off the top of the continent. And as it does, as it removes all of that, it draws down into the ocean basins, we believe. So a lot of that Grand Staircase material, it's interesting because when you go to the Grand Canyon National Park, I have yet to find a sign anywhere that talks about the mile of missing strata above us, because I don't think that they have any answer to it. It's not like it's just eroded and melted into the landscape. Even if it was there in layers, it should erode, and weathering and erosion should leave it on the landscape, but, covering it. It's not like it's just eroded into the landscape. It's literally gone, as if it was stripped off the continents. Now, how do you strip away a mile of sediment and just remove any trace of it? It's really hard to do that unless you have a really big event, like a big water event. So that's what we see with that. And then the layers of the Grand Canyon, as the canyon was carved down through, one of the questions people ask is, where's all the sediment from the Grand Canyon? The 900 to 1,000 cubic miles of missing sediment from the Grand Canyon, where did that go? Well, interesting, what you should actually ask is not necessarily where is it. The question you really should ask is, where isn't it? And I'll tell you where it isn't. It's not at the end of the Grand Canyon and the Colorado River. Now, if the river was the mechanism to carve the Grand Canyon, if the river, there we go, we'll go back to that one. If the river pulled out all that sediment, then the river should continue carrying it out like a giant conveyor belt. We should find all that sediment at the end of the Colorado River as it dumps into the Sea of Cortez. We should find a massive, huge delta. Roughly 1,000 cubic miles of dirt should be piled up in the big delta, right? Big rivers make big deltas, right? Look at the end of the Amazon River. What do we find? Amazon River Delta. The end of the Mississippi River. What do we find? Mississippi River Delta. The Nile River. What do we find? The Nile River Delta, the biblical land of Goshen. So what we're seeing here when you go to the end of the Colorado River is you go off this picture, it kind of goes up and around and then goes basically straight south. You follow the river down to the end, and guess what? No major delta. Only a teeny tiny delta is found. Where's all this dirt? It's not where the river went. It's actually found further west and southwest of there, blanketing parts of the Mojave Desert and the Anza Borrego Desert. And some geologists actually believe that the LA Basin sits on top of Grand Canyon sediments, as if a huge amount of water dumped it all across there, all the way to the Pacific Ocean. The river goes out and it goes straight south, yet all the dirt is found hundreds of miles to the west. Well, hey, wait a minute. If the river carved it and the river was a conveyor belt, why didn't the river dump all the dirt? Well, instead of asking that question, you should ask, did the river even carve it? And the answer is blatantly, glaringly, no. You should find the delta, but we don't find a delta. So not only are we missing a mile of vertical strata on top of the Grand Canyon, we're also missing the 900 to 1,000 cubic miles of sediment from the Grand Canyon itself. It's missing from where it should be. And where we find it is not where they've expected it, which again is one of the reasons that geologists are saying, doesn't look like this river could do it, because it doesn't match up anything like we'd expect to find from a river. So I'm glad you mentioned that, because that Grand Staircase is a great example. And again, I have yet to see a sign in the Grand Canyon National Park talking about all that missing strata. You see it when you go to north. In fact, you see remnants of it on both ends of the Grand Canyon. You can see when you're approaching Grand Canyon from the south, coming to the main south entrance, you see about 900 feet of a remnant butte called Red Butte left behind. It sits on top of the Kaibab limestone made up of the Moen Copley and the Chinle Formation with a little lava cap protecting the very top of it. Then you go to the eastern end of the Grand Canyon, you look out over the Painted Desert, and you can see another little flat-top mesa out there called Cedar Mountain. And Cedar Mountain, again, is roughly 900 feet tall, again, made up of the Moenkopi and the Chinle Formation, a little bit of that Shinnerup conglomerate at the top. And that's part of the Grand Staircase sequence that's been stripped away from the top of the Grand Canyon and completely removed off of there. So we're actually missing more material than we have left behind, and nobody wants to talk about it. But when you realize that, you're like, something really big has happened here. And it's not only has it kind of removed that material, it's made it disappear. And so we believe that drained into the ocean basins, was stripped off the continents. Great questions, man. You guys got some really good questions tonight. Anybody else? Yeah.
How many different places like the Grand Canyon are there around the world?
That is a great question that I think needs a lot more research. How many places like the Grand Canyon are there around the world? Well, the Grand Canyon is pretty unique. It took a special set of circumstances to really give us the Grand Canyon, but certainly we know that there are other canyons that were formed by catastrophic processes. Like I talked about before, Lake Missoula spilling through there, carving the Columbia River Gorge. There are other canyons. I'm very curious to investigate canyons like Copper Canyon down in Mexico. That is one of the big, large canyons as well. The second largest canyon in the United States is Palo Duro Canyon in kind of the panhandle area of Texas by Amarillo. I've been there, studied it, and that to me also looks like a lake spillover area. And I think if I remember right, I just did a brief looking into it, and I think it was waters to the northwest of there that appeared to a pond that didn't spill through there. Black Canyon of the Gunnison in Colorado. Anybody been there before? Black Canyon, and I was just there about a month ago, researching and looking at that area. Again, the idea there is that river, the Gunnison River, slowly carved out that canyon into solid bedrock. Doesn't make sense. But yet you begin to look at the geology of the landscape, you begin to do elevation mapping and models, and you can see direct physical evidence. There was a massive, huge, impounded lake system to the northeast of there. And so if there's a big area depression that looks like it held a tremendous amount of water, why could that not be the same scenario we're talking about here? So I think there needs to be some good science research done on that too, and to say, hey, could this have also been a catastrophically formed canyon? I think we need to examine multiple canyons around the world and say, hey, what do we see with great technology like satellite imagery? It's only been recently available to us, but with the big picture view, you can really get an understanding of the big picture event. So I think there are many other canyons that could be like this. They all need research. And, as much as I love the Grand Canyon, I would love to see people study other places. Because the Grand Canyon is the place to come study, even in creation geology. Everybody loves Grand Canyon, Mount St. Helens. Everybody's got to talk on those two places. But my research and work has been, hey, I know Grand Canyon, but let's look at the surrounding landscape. And that's why we're trying to bring in additional geologists to look not just the Grand Canyon, but the surrounding area. What do we see to the east of the Grand Canyon that shows us how this place was formed? What do we see to the west of the Grand Canyon that shows us how this place was formed? When you begin to map out and put the big picture view together, it really helps tell a story. So I think we need to do more research. I think we need people to go out to all these places and ask those questions from the very foundation once again and say, what happened here? What could have happened here? And begin to look at it through this eye of catastrophe, which is becoming the norm in science and geology. Great question there.
This is just an interesting question. So did the Great Lakes, from your perspective, did it just sort of get lucky because it got an Niagara Falls and was really subject to canyon spill off?
Yeah, I think the Great Lakes have drainage coming off of them. This would be an impounded lake with no exit route and water that rises and fills faster than it can either evaporate or soak into the landscape. And so what happens here, it's a very special circumstance. And that's why the Grand Canyon is the Grand Canyon. And I think other lake systems, either they have drainages coming in and out, or it soaks into the landscape, or evaporation, things like that happen. This is a very unique location. And so, again, it takes special kind of geology to give us what we have here. So it's kind of a matter of the landscape and what do we have going on in there that helps determine what has happened ultimately with that. But I think looking at it, there are many other lakes or ancient ancestral lakes that are no longer there that have canyons that we need to relook at and say, maybe there's more evidence to look at in the earth. Good question. Yeah?
Have you done any study of the Colorado Valley, especially from Cleveland down to
I have not done any studies on the Cuyahoga Valley at all. Nope. I think somebody here needs to do that. Who wants to volunteer? Yeah, I would love to. Yeah, I'd love to travel around. I used to live in Indiana. That was the closest I've been to this region. But back then, when I was in high school, I wasn't thinking rocks and geology and looking at the landscape. Now, every time I'm driving, I can't ignore the landscape and rocks and geology. I can't even watch a movie with my kids at home, and I'll be like, ooh, what is that rock layer? Ooh, where's that filmed? Even the Star Wars movies, you're watching and like, ooh, that's the Pete Sandstone they're flying through, it's stuck in there. So even driving up here, I flew into Columbus and was driving through, like looking at ooh, what are all these hummocks and these hills? And I'm like piecing together, road cuts, and just fascinating. I went to the museum early this afternoon and got to see some of the local geology you guys have here. And I'm like, ooh, I need to get out here again and just spend a week running around and looking at stuff. So I've not really studied any of the valleys, geology around here, but I think someone who lives here, anybody else, ought to take a look at that and study it. It'd be a great project, I think. And there's also a great university not too far from here. We're at Cedarville, and I know John Whitmore would be fascinated to work with anybody who wants to do that study, or any potential students that want to go into geology. I would say it's the best creation geology program in the nation. It's one of the few, I think there's only 2, maybe 3 Christian universities that have a young earth creation geology program. So pretty amazing. And it's in your backyard, so pretty cool. But yes, yeah.
Maybe you spoke to this, but do you have any speculation on the destruction of Hopi Lake? I mean, in terms of what actually caused that catastrophe?
That's a great question. Yes, I do. So when we look at Hopi Lake, let me find it real quick. There's a few different ideas that have been proposed. We don't know exactly because we weren't there, but a few different ideas that have been proposed for its spillover and breach. One of those ideas is simply by spillover. In other words, you fill the bowl beyond its capacity, it spills over. Looking at the landscape, the place that it would spill over first happens to be where we see the Little Colorado River Gorge come into. That place where, let's see if I can find that video actually. The place where we would see it come in at is one of the lowest places on the entire Colorado Plateau. Today, there's one area slightly lower just north of there, but we believe it's been downturned. It's actually been pushed down. When the Grand Canyon was formed and all that material was ripped out, it caused a tilting on the Kaibab Plateau to kind of rise up in the north or in the south side of it, and in the back side it pushed down the landscape. But when the canyon was carved and when the Little Colorado River Gorge you see here came in, this would be the first place to spill over. So like if you have a bowl and if it has an uneven rim, well, the lowest point along that rim is where water is going to spill over first. And it just so happens to be, this is where it happened. The lowest point is where we happen to see the spillover. So it simply could have been spillover. No reason why that couldn't have been. Other ideas that have been proposed are perhaps there was an earthquake. There are lots of fault lines actually that run right through here. Right nearby, actually right through here, there's what we call the Butte Fault. The Butte Fault runs kind of right through there, and there's a number of other faults. There's a big fault line that runs through Bright Angel Canyon, and that fault line runs about 100 miles. It's a massive fault line. There's a lot of fault and tectonic activity, so it could have been an earthquake shaking a fracture, or even caused liquefaction within there that started water to spill through there. So that's another idea. Also, this whole plateau, most of it is actually limestone. Limestone is very prone to water eating away at it, causing karst formations and dissolving and opening up springs. And it could have been a small spring that opened up and a small tunnel within the rocks, and then the water dissolved and opened up. That's another idea. Probably my least favorite of all the ideas, but it's been proposed. And then a fourth one, and this was actually when Dr. Whitmore and I were out there, I want to say 2 years ago with his geology students. We were looking out there in Hopi Lake Basin in a place called the Hopi Buttes, where there's a bunch of volcanoes out there. And these volcanoes erupted into this lake. There's direct evidence for that there. And the idea, this was right around the big volcano, I can't remember the name of it, but I think it was like down in near like Tonga or something like that, the big volcanic eruption in the ocean that we can see the video, and a big eruption that sent out shockwaves and created a tsunami. See, the idea was, John and I were looking at it, he said, here's an idea. What if these volcanoes erupting into Hopi Lake created a tsunami wave that traveled across the lake, and as it hit this outer edge, maybe it breached the edge, and this water came spilling over the plateau and started that trigger of it. So any 4 of those ideas could actually start this whole event going. And all we need is one of them to work. But we have 4 different possibilities. I tend to favor either just the pure lake spillover or perhaps a tsunami-driven event, perhaps. There's even, well, there's actually a 5th one, perhaps the impact of meteor crater could have had something to do with it. And I don't have a picture of that on here, I don't think. But meteor crater, it's actually completely underwater here. Meteor crater is not too far in this bottom edge of Hopi Lake you can see down there. And it's near the shoreline. It's actually shallow enough that it could have the impact to create the crater and could have propelled the tsunami wave across there. It also has other implications that it could have because it impacted into what we call the Coconino Sandstone, which has a massive aquifer. It could have impacted into this underground aquifer and created a water hammer effect that actually sent compressed, water that doesn't really compress and squeeze down, but could have sent a shock wave through the water to travel through this aquifer and cause these volcanoes to erupt. Because as they're pushing out, these volcanoes happen to be formed right near a mountainous area. Well, mountains, like they rise up, they also go down. And it's like almost like a wall. If you have a shock wave going through this water and it hits this wall, that energy has nowhere to go but vertically. So it could have fractured, literally like fracking. You've heard about fracking and it breaks open the rocks and we get all the gas and water released. It literally could have fracked those rocks and sent water down into the mantle area where it's now interacting with the magma and the heat and lava and erupts as these massive phreatomagmatic, massive volcanic eruptions. And that's what these volcanoes are. They are marred diatreme volcanoes, which shows us that they were exploding in and through water. So that's an idea. It's a brand new idea. We don't even have a model worked out yet for it, but it's one that we're kind of looking at. And there's direct evidence. There's about 300 feet, 200 to 300 feet of a lake basin within Meteor Crater. If you go stand on the edge of Meteor Crater, and I was just there like 3 weeks ago, you look at it, it's not even as deep as what it was. The impact actually was about 300 feet down, and what you find on top of there is actually freshwater lake deposits. So it may have collected from rainwater and made a little lake. And what could have been this water was impacted into, water came out of the tsunami, and some of that came and washed back over into Meteor Crater, and then it all dried up and evaporated away since then. It's an idea, it's a theory, it's not even a hypothesis or model yet, but there is a 5th mechanism. So any one of these 5 mechanisms could explain the trigger an event. And again, all we need is one of those things to work, and we've got it. It's a great question. I don't think anyone's ever asked that before. I like it. All right, we have time for one more question, I hear. One more question. All right, you got it.
Okay, those 5 ideas you just had, I can see how any one of those would have still part of the Great Canyon except the earthquake. How would that occur?
So the earthquake would fracture the wall. So imagine you have water, you have a wall like an earthen dam, the water's rising up against there. The fracture line, the Butte Fault actually goes right through that wall. So if you've got a wall and you break the wall because of the earthquake, now the water goes through the wall. So it's just a mechanism to start the water traveling through. Any one of those 5 mechanisms can start that water traveling through. And that could be one of them. Certainly we saw a lot of movement, and we do believe even when the canyon was carved, there were earthquakes and things going on because we see a lot of what we call isostatic rebound, where the land is moving in response to all that weight being stripped out. You remove 1,000 cubic miles of rock and dirt, and that's a lot of weight and pressure that gets taken off the surface. And tectonic forces underneath that are usually held in place, now that weight is no longer there, so it rebounds. We kind of a flexural response, a isostatic rebound push up, and so we see the Kaibab and Coconino plateaus today are not flat, they're actually tilted. Both are tilted up and back away from the Grand Canyon, as if this whole plateau was tilted back. And so we know that there were earthquakes going off when the Grand Canyon was even being carved. All that response triggered fault lines and fractures in the landscape. Now, did they happen at the beginning and help the canyon be formed? Did they happen during it? We don't know exactly yet. Could have been both. Yeah, great. Well, thank you guys for tonight. I can stick around as long as you want. And again, on that back table, feel free to sign up. You can either do the QR code or the website on there. Sign up to win a free rim tour of the Grand Canyon. Also, I've got flyers back there that talk about the daily rim tours, hiking, backpacking, river trips, everything that we do. We run tours year-round, every day except for Sunday. We have multiple tours offered at the Grand Canyon, and I would love to see you guys out there. It'd be fantastic to come and see the Grand Canyon and hear a little bit more about it and put all these pictures and stories and everything, put it to life, and again, see the power of God on display. Not only His glory and His grandeur, but His love, His mercy, and His heart of redemption that's on display. Amen? All right.
Give that a hand. Well, thank you very much for coming out. Really, really appreciate that. It was a wonderful lecture going through that and giving us a lot of thought, a lot of food for thought. We do have that donation box back there that helps us do more of these events, so please feel free if you have some spare money you can throw that way. We love to have more of these. We do about once a quarter, so our next one should be sometime around September, October, and we'll let you guys know on the website and Facebook events, and those green cards will really help us get you guys that information as well. I want to thank you for coming out, and we appreciate you showing up. Thank you very much.